All right, so let's take a look at this problem. This one is called remove nth node from the end of the list. And when you're looking at a linked list problem, just know that typically one of the solutions that you might come across in a pretty common fashion is using multiple iterators where maybe something is iterating fast and something's iterating slow. And so if we look at this problem, it's given the head of a linked list, remove the nth node from the end of the list and return its head. So we also know we need to return the head. And a common way to do that is to also use what is known as like a dummy head. And the dummy node rather will point to the head. So that way at the end of the problem, we can just say return dummy.next. So that way we don't lose track of where the head is as we iterate this list and change out a value. So if you create a dummy node, you point it to the head. Now, what would we do after this? Well, we want to remove, again, the nth node from the end of the list. So if they gave us 2, we're going to remove the second value from the end of the list. And so maybe the fast pointer would come through, maybe go 1, 2, or 3, and 4, 5, all the way to the end. But it needs to have a way where it stops somewhere here that the slow node can come behind it and be at this 3 spot. Reason being, we want to remove 4. A common way to remove a node from a linked list is just to take the reference for that node's next node and change it to the one after it. So we could change what 3 points to instead of 4, change it to 5. Okay, so how do we get the slow node to 3? So if we're iterating with the fast node, 1, 2, maybe we go to 3. Let's think about this. So if we hit 2, and then we were to say, all right, we need to keep going until the fast node no longer has a next value. So essentially we want to stop when it gets to 5. So then 1, 2, 3 spots. If you think about that, that's also how many spots the slow node would have to go in order to get to here. So if we had a fast node and it got to 2, and then we had a slow node behind it, and we said, go until the fast node is at the very end. So basically where fast.next equals null. So if we're at 2, now all we have to do with the slow is come from behind at 1. So slow goes to 1, fast goes to 3, slow goes to 2, fast goes to 4, slow goes to 3, fast goes to 5, and now fast.next is null. So we're exactly where we want to be for slow. So let's go ahead and try to implement that now. So here, as I said, a common approach whenever you want to return the head at the end of the problem is that you would potentially create this dummy node. You're going to use it to point to the head of the list. And you see here in our class that there's actually a constructor to not only pass a value for the dummy, but also say what its next node is. So we'll do that. So new list node, and we'll say the value is 0, and then we want to point it to the head. Now, as I was saying, it's very common to use one or more iterators for linked list problems. So we're going to create our slow and our fast iterator. So we'll actually just go ahead and point that to dummy, and we'll also point our slow iterator to dummy. So these are sitting in front of head, and we're going to start iterating through the list. And as we already discussed, we're just going to iterate from the beginning of the list for the fast node to this 2 spot, because by the time that the fast node gets to the end of the list, our slow node will be at this 3 node. So we'll say int I equals 0, I is less than n, which is 2 spots from the end in our sample, but also it could be any other value that is provided. And then we'll just say I++, so your common for loop structure. And then this is just us iterating through the list, changing the fast value to the next value. And then after it is where we need it to be, now you just do like a while loop to essentially get your fast node to the end of the list. So while fast.next is not equal to null. This is where we're going to be iterating both the slow iterator and the fast iterator together at the same time. So that way, once the fast iterator is at the very end of the list, the slow iterator will be where we want it to be. So we'll say fast equals fast.next. And we'll say slow equals slow.next. And then after we've done that, now the slow node is exactly where we want it to be, as we've discussed. It should be at this 3 node. Now, in order to remove the 4 node, you use that common approach to remove a node from a linked list, and that is to say the next node for this 3 node needs to point to 5. So to do that, we'll just say slow.next equals slow.next.next. And now that we have done that, we need to also return our head node, and that is exactly why we created that dummy node. So we'll just say return dummy.next, because remember the next node for the dummy value is the head. And that is it. So we'll go ahead and submit. And the big O for this is just going to be the length of the list, because you're just iterating through the list at least one time to essentially get that fast node to the end, and then you're just updating that that slow node's next value to the one after it. And then we have constant space because we're allocating, yes, a fast, slow, and a dummy list node, but we're not allocating, nodes for everywhere in the list, so we're not making a copy of this list or anything like that, so just be constant space. All right, that's it for this problem. If you have any questions, please let me know in the comments below. If you'd like to see any other questions in particular, please also let me know, and take a moment to like and subscribe for future content.